Hello and welcome to this video on an introduction to piecewise functions. Before I explain what piecewise functions are, I want to show an example of them using the word problem you see on screen now. Once we've worked through it together, what piecewise functions are will become very clear. In this particular word problem, we are looking at an example where someone is at their first job and they earn $12 per hour. If they are working more than 40 hours within 1 week, they're getting paid time and a half. That is overtime pay and very common among hourly workers. And it means that they're just making their original wage, in this case $12 per hour, plus 50% more just for those overtime hours, the ones beyond the 40-hour standard work week. So we'll answer some main questions like how much money you would earn a week if you worked 50 total hours, and how many hours you might need to work in order to earn $696 in just 1 week. And in this video, we will represent this situation with using tables, equations, and graphs. So let's get started with this problem. So when I am going to work on this problem, I want to first decide and write out a table. And the X values that I'm going to use are going to represent the number of hours total in that week. And then the Y value is going to represent the dollars earned. So I'm going to make an XY table off in the corner here. And I could write hours for X and then put a little dollar sign for Y. And I want to think about this in terms of an easy approach. So I'm going to do this in increments of 10 to start out with. So if I think about working 0 hours, that's easy. I didn't make any money. But now if I am going to start working 10 hours, well, that means I do 10 hours times $12 per hour, meaning that I would have made $120. And then I can do the same thing for $20. That's $240 for 20 hours. I could do 30 hours. That would be $360. And then finally, a full 40-hour full-time job would get me $480 from my hourly wage at this job. And this is a very easy table to find an equation for. We can just think about using our y-intercept and slope to get a linear equation. So I'm going to think about y-intercept first. My y-intercept is when x is 0, and I can tell that my y is 0. So I know that my b value, which is my y-intercept, is going to be 0. That's easy. But next, I want to think about how I would get the slope of this an equation that would match this graph. So I just need to see how much y is changing and then divide that by how much x is changing. So the y went up by 120 and the x went up by 10. So that means that my m for slope is going to be 120 divided by 10, which is going to be equal to 12. And just to make sure that I did this correctly, I can see if that slope is staying the same. If I go from 120 to 240, that's 120 again for a difference. And from 10 up to 20, that's 10 again. And that stays constant throughout this whole table. So I know that a line would be a good thing to use to model it, and that my slope is staying as 12. So my equation at the bottom for this table is y is equal to 12x, where my slope was 12, always next to the x, plus 0. And if I wanted to, I could not even worry about that 0 and just think of it as the equation being y is equal to 12x. Now we are ready to start thinking about the more challenging part of this problem, and that is when there is overtime pay included as well. I want to stay with my increments of 10. So my first increment of 10 would be going up to 50. So this is answering question number 1. If we can figure out how much we make in a week when we have worked 50 hours. So I already know that for 40 hours, I would make $480. So I've already made that $480. I get to take those first 40 hours and multiply them by 12 again, like I might have done in the table from earlier. But I need to add those next 10 hours. So if my wage is time and a half, I would need to think about what that means. I need to increase my $12 per hour by 50%. When I'm trying to figure out what's going on with those next 10 hours, I need to first figure out what 50% of 12 is. And I can do that up here in the corner. So 50% of 12 is equal to 6. And I can then add 6 plus 12, which would be the same thing as 50% plus 100%, giving me 18 total. 18 total. Now that I know that that 18 is there, that 18 is going to be my hourly wage for just the overtime hours. So with those another 10 hours past the 40 that I've already done, and I can even kind of write this out as simple as possible. So I could do 40 hours times 10, $12 per hour, which is the 480 I had before, and then 10 more hours being multiplied by $18 per hour, which gives me a total of $660. Okay, so now that we have that for $50, we can go up to $60 and use the exact same method that we just did. So to get the total for 60 hours in the week, it would be 40 and then being multiplied by 12 again. And then I'm going to add another 20 hours past my 40-hour week. It would be $18 per each of those overtime hours. And that would give me a grand total of $840 for that week, working 60 hours. And you can see, looking back at the problem, that for $696, that's between 50 and 60 hours. And in fact, it is exactly $36 more than the $660 I have right here. So all I need to do is, well, that's $18 twice would make 36 for the difference. So that means that 52 hours would be the answer for number 2. So now that I have 50 and 60, I want to do one more row just to make sure that we have the same constant rate of growth. Because so far from 660 to 840, that's $180 difference. So now if I were to do this with 70, let's check that, see if it's still the same constant growth rate. And so I have 40 times 12 plus I have 30 hours times $18 for overtime. And that would give me a grand total of $1,020. And we can see, well, yes, that is a growth of 180 again. Now that we have everything in a neat table, let's get the equation for this second table for the other part of this equation. With this problem, we have our x is increasing by 10. So we have 10 right here. And then our y is increasing, as I stated earlier, by 180. And that means our slope, m, is going to be equal to 180 over 10, which is equal to 18. And we have found our slope of the second part of this function. So if we look at where these points are, we don't have a y-intercept ready to go, so we need to use something called point-slope form to get our y-intercept. So we're going to do y minus our first y point, 660, and then that is going to be equal to our slope of 18, 180 over 10, times x minus our first x point of that table, which was 50. And all you need to know once you have set this up is just get y by itself completely and simplify the right side as well. And you can see here I've simplified our equation. So our second table with our information on overtime hours, it comes out to an equation of y equals 18x minus 240. So the main thing to notice in what happened here is we started out with a table that we got an equation for, y equals 12x. And then we got a second table with some of the overtime information on it, like 50, 60, or 70 hours in a week. And that needed a separate equation. And that's kind of what is going into a piecewise function, where you have one word problem, but within that word problem, you have separate situations and separate scenarios that need their own equations. So what we would do would be to go, and when we can scroll down a little bit on our page, and we need to write down our equations. So we have one equation that was 12x, or y equals 12x, and one equation that was 18x minus 240. And the second part of a piecewise function is that these two equations aren't being used no matter what. You have to tell your reader, well, you have to use this first equation if you're working between 0 and 40 hours. But if you work more than 40 hours, then you have to use the second equation to figure out your total pay. So what I basically just said means that the first equation is for when x is between 0 and 40 hours. And I can use this inequality. 0 is less than or equal to x, which is less than or equal to 40. And then our second equation, you're only using if you work more than 40 hours. And if you hear the words more than 40 hours or just more than, that is always going to be a greater than symbol. So that means that our second equation is going to be used when x is bigger than 40. And a good way to write out this sort of equation is in kind of a standard way. And we would write out f of x here on the side because f of x and y both being the same, they're equal to both of these. We have both of these equations being representing the situation we've been working on in this video. And now we've represented this word problem up at the top with two different representations. We have tables to represent the two parts, and now we have an equation for both parts that all come together into one big function. All that's left to do is to look at the graphing portion of this scenario. I'm using this graphing application to display the graphical representation of this same word problem. I've put my two equations, y equals 12x and y equals 18x minus 240, up at the top left. You can see I've typed in brackets next to them the inequality that would go with each of these two equations. Then I'm getting paid $12 per every X hour for 0 hours up to 40 hours. And I'm getting paid, or my pay is being represented by 18x minus 240 for my total money if I work more than 40 hours, x being greater than 40. The red line starts at 0 and goes all the way up, and you can kind of look through all of these and see how much money you're making as it follows it all the way up to 40. And you can see that's because x is less than or equal to 40. I make $480. But then if I look at the blue line, well, if I work, say, 60 hours at what number I found earlier, I know that that's still 840, and I could follow that down to 52 hours, and I know that's the answer from earlier, 696, and go down to 50 hours, and I know that that's 660 from earlier as well. But if I follow it all the way down to where they meet, I have an open circle here for the blue line at 40. That is because x is greater than 40, and we can't include 40 in that second equation. 40 from this side would have to be included in the red equation. And that will be a very big important point as we get further into piecewise functions. That concludes this video on an intro into piecewise functions using a word problem example to show how it might model the real world. Thank you for watching.